In this video we are going to discuss about first step of simulation, and it is a geometry idealization, that how to modify a CAD part to make it more suitable for simulation purpose. We know that CAD geometry often contain many small details that are not relevant for a simulation purpose, and for that we have to edit and repair our geometry. The important thing is that the idealized part is not necessarily a perfect twin of our CAD part. That idealized part should have characteristic or presentation that will reflect the real world operating condition of CAD part or product. So for that, the CAD geometry can or should be simplified through the geometric repair and editing operation. In demonstration 1, we will start with this model which contain many small details and features, and by editing and repairing our CAD geometry we will come up with this model, and it is our idealized part which is more suitable for a simulation purpose. So for that, Simcenter offers most advanced modeling technology, and it is a synchronized technology. It allows us to modify any part very quickly and easily, even if there is no information that how this part was created. In this picture you can see that it is also smart enough to recognize a feature and allow us to edit and modify those features directly, even if there is no any feature history. In many cases we have a part feature history and we do not want to affect our part history. So in this case, synchronized technology allows us to edit our CAD geometry independently of part feature history. The another thing is we can also import a dump geometry and prepare it for a simulation purpose. Let's move to our demonstration 1. In this demonstration we will see that how we can do geometry idealization. Here you can see right now we are in a Simcenter environment where I have opened one part which is look like aluminium cover, and it is going to screw with some type of enclosed body through these holes, and shaft might be passes through this big hole. So it is kind of mechanical part which can be used anywhere in mechanical industry. The people who are using NX, these environments look familiar to them because Simcenter is a simulation part of NX and it is directly integrated to NX. So the people who are using NX, they can right away move from NX CAD environment to the Simcenter simulation environment. But what about the people who are using different type of CAD systems such as Creo, Solid Edge, SolidWorks? So Simcenter has a tool that can directly embed with any other CAD system available in market. So they can use their native file or they can use a global file such as IJS, JT or STEP to import their model into the Simcenter simulation. So before we move forward, let's get some information about the part. So in model history you can see that we have only a single body. We do not have any other construction step that how this part was created. So once you are in modeling environment, you can create or modify the CAD geometry as per your requirement. But what if once you are in a simulation environment and you have to modify or edit your geometry for simulation purpose? So Simcenter offers the most advanced modeling technology, and it is a synchronized modeling technology. It offers us a different type of tool to modify our geometry as per our requirement and prepare it for a simulation purpose. So before we do the simplification of our CAD geometry, let's create an idealized part, means perfect copy of original part. Because in many industries or organization there is a authority right that authorized person can only make changes to the original CAD part. So usually design engineer and analyst are creating a copy of original part and prepare the geometry for a simulation. So here you can see that this aluminum cover contain many small details that are not relevant for simulation purpose, such as this to depress surface. So I want to replace this surface with this one, and we have real-time preview of what we will get, so it is look good for us. So let's hit apply. Same way I need to replace this surface with this one, and it is look good, it is good for me. So let's hit OK and done that. So here, as we move forward, here you can see that these features, it is look like a rubber strip, and it is going to use that it can be used for to prevent penetration with another part. So we know that rubber is a less stiffer material than aluminum, so it will not going to affect structural performance of our aluminum cover that much. So it is better that we delete this rubber strip. So we can right away able to remove our rubber strip. So here we have different type of option, and we are going to select boss or pocket type of faces, and we will select one of them. So it will automatically recognize and select all the rubber strip feature, and it is look good for me. So let's hit OK. We can also delete holes. So in our case, this cover is going to screw with some type of enclosed body, and in this hole there will be a screw, and I'm considering that screw has a same material as cover. So we are going to delete these holes, and let's select those holes. I also want to remove these holes, so it is look good for me. So let's delete all the holes. So from design engineer, I have information that the shaft has a diameter of 40 millimeter. So we can right away measure the diameter of this hole, and here we have actual value of our radius is about 57, and we want it 40. So we can right away change the value of radius and resize our hole as per our requirement. So this way we can easily and very rapidly modify our geometry using synchronized technology. The more important feature is idealized geometry. So what if there is a number of holes and we want to remove at once? So by using idealized geometry, we can select our body and define that I need to remove the hole which has a diameter less than or equal to 20 millimeter. So after defining, it is automatically select all the holes available in geometry which are less than or equal to 20 millimeter, and it is look good for me. So let's hit OK. So this way, using synchronized modeling, we can right away modify or repair our CAD geometry and prepare it for simulation purpose. So if my colleague or analyst want to do the detailed analysis and remain all the holes as it is, because he is going to do the detailed analysis and he is considering that screw has a different material than our aluminum cover. So he want to know the performance or the behavior of the all holes during the operating condition, so they can remain those hole during the analysis. So it is a good practice to consider real world operating condition to simplification of our CAD geometry. In our cases, for simple structure analysis, we do not require any hole. We are going to consider it as all holes are filled with same material. So it is good practice that we consider a real world operating condition during a simplification of our geometry. In following video, we will discuss about second step of simulation, and it is finite element meshing, that how to build a mesh that will give us a reliable simulation result.